Welcome back, guys. Good afternoon to you, and welcome to Cheenta Statistics Analytics Department. And we are today here with today's problem. As usual, I will just say the opening line over here that if you have not solved the problems, pause the video, do it yourself, and then come back and see the solution. What's the solution? Okay, guys. So let's get started. So today's problem actually was given in our WhatsApp group. If by the way, if you don't know where to get the WhatsApp group, you can get in. Like I will share the link now in the comment sections below, so you can check it now. There is a WhatsApp group given, so get in like to get all updates of all this stuff going over with our national groups and national students preparing for the exam. You can join the WhatsApp group if you please, if you want to like be a part of them. Okay, coming back to the problem, in the WhatsApp group, one student gave this problem, and I thought, and I made a mistake. Okay, while explaining it to her, and that is a mistake. I'm going to tell you where I did a mistake, and then some other student corrected me. So I think if I can do a mistake, there is a chance that others will also do a mistake, and this is a very simple idea, and so I want to share it with you. Okay, guys. So coming back to this problem, um, so this problem is revolves around the fact about the symmetric random variable. Okay, it's asking x is a symmetric random variable, and like what are the which of the following like paths are true. Okay, so let's check this out how to do this problem. And first of all, let's define symmetric random variable. So by and as per the definition of Wikipedia, this is a symmetric random variable that it's said a probability distribution is said to be symmetric if there exists a value x naught, symmetric around x naught if there exists a value x naught, such that if this is a PDF of that for continuous distribution, continuous random variables, then f of it means that the idea is that there is x naught, so f of x naught plus this is x naught plus delta, so the whatever the height of the density will be here will be same as the height of the density here. Okay, that is x minus delta. So f of x naught minus delta is equal to f of x naught plus delta. Okay, for all delta real numbers. So this is the basic idea. This is the definition of symmetric like random variable. In case of probability, then like mass function, you can just do the same thing. Probability x naught, like x is equal to x naught plus alpha is equal to probability x is equal to x naught minus alpha for some alpha. You can do this. Okay, this is a definition of this, but let's just focus on this like continuous distributions, and I will give the homework of the discrete distributions as your homework, guys. Okay, so coming back to this, let's see the problem. It's x is a discrete random, it's x random variable whose distribution is symmetric around 10. Let's assume it's a continuous random variable, and let's do the problem first. So this is the definition that it has a PDF has this. PDF is this for all real numbers delta. So now let's come back to the problem that which of the following options are true. And I made like a small error in this. In fact, it's a big error. I made an error in this, and the error is this, that I thought that expectation of, I sort of didn't think it mathematically, I was thinking geometrically. So expectation of x will be the mean. In fact, that is geometrically true if you think that, like, let's take this. So it's symmetric. So there will be a maximum around that point x naught, right? Symmetric, and it will usually look like this. Okay, it will usually look like this, right? We'll attain a maximum over here, and then it will behave the same way over here. Okay, and it will behave the same way over here, whatever it is. The problem is that I thought that since like it's equally distributed, so integration x, so fx dx minus infinity to infinity, this will be the expectation of x, right? This will be equal to what? This will be equal to, you can understand that x is around x naught. So what we do a small variable change. So we do x naught, we replace this by, we replace x by x is equal to x naught plus z. Okay, so we replace the x naught plus z, and therefore dx dz remains same. F of x remains f of x naught plus z dz. Okay, and this turns out to be what? Minus infinity to infinity, again same thing. Now if you just do the calculation, you just see minus infinity to infinity, this x naught fx naught plus z dz will come up, and there's an extra term that will come up, that is integration minus infinity to infinity z f of x naught plus d. Okay, let me just clear this out. Let me just give you the mathematics. Expectation of x is equal to integration of minus infinity to infinity x fx dx if it exists. Okay, the thing is that I assumed it exists and did this problem. That was the like geometrically, but it may not exist, and I will give an example. It's minus, and now what you do is that you use the symmetry of the, you want to use the symmetry of the random variable of the distribution density function fx. So what you do is that you change the random variable, the variable to x naught plus, let's say, z. So you get here x naught plus z, f of x naught plus z, okay, and dx is equal to dz by this change. And what you get the following two things, that minus infinity infinity x naught f of x naught plus z dz plus integration minus x naught plus z f of x naught plus this. So if you observe that, in fact, what is happening over here is that this is actually an odd function in z. Okay, why? Because this is same as, so since f of x naught plus z is equal to f of x naught minus z, so it can be written as, this thing is what? This thing is equal to x naught times minus infinity to infinity f of x naught plus z, which is equal to 1 since it's a density function. So this is actually equal to 1, x naught, okay? X naught times the sum of the like, integration of the density function. But this is where it was a problem, that if you divide it into two halves, minus infinity to 0, z fx naught plus z, plus in 0 to infinity z fx naught plus z, this will turn out to be, so this is an even function around x naught, okay, and this is an odd function, okay. So therefore what will happen is that like this is an even function, that's it, this is an even function, and this is an odd function. So therefore this is an odd function, and this will turn out to be 0. But this will turn out to be 0 even only if this integration exists, okay. So this turn out to be 0 even only if these two integrations are finite, but these two integrations are not finite, okay. We have like may not be finite, are not finite, I'm sorry. If it may not be finite, then if it's not finite, we cannot tell that. And one example it is not finite is Cauchy distribution, okay. It looks exactly the same. I'm just copying the image from Wikipedia, but in that integration is not finite, okay. This two integrations separate, you can calculate that and you can see that they're not finite, okay. Therefore we cannot do that. So this exists if and only if these two are finite and these are indefinite integration. So this is the basic idea, and if it exists, then they must be of opposite sign and they must cancel each other, but they are not finite, okay. And they are not always finite is the case always. And the example is Cauchy distribution, and this is something, but if it's finite, you can see this will turn out to be 0 and it will turn out to be x naught. So if it exists, then it's finite. So I sort of missed this point, but I'm glad the students out in the group mentioned that. I'm really glad to them. So this is something that it is, so this is equal to x 10 if and only if the expectation exists. Expectation exists, okay. Otherwise not. So in there can be cases, for example, Cauchy distribution where the expectation may not exist, okay. It's a very good idea to understand that. Okay, so now coming back to the probability of this event, like the rest of the options, let's check that, and it will be easily understandable by the idea of like the geometry of the whole thing. And you can understand it very easily, that integration, since it's symmetric, so integration minus infinity to x naught fx dx will be equal to half, which will be equal to integration x naught to infinity fx dx, okay. And what will happen is the following, that therefore it implies that probability x greater than x naught is equal to half is equal to probability x less than x naught, like a less than equal to x naught, okay, and greater than equal to x naught, you can say. This is very interesting, this is very important. And let's say, yeah, x greater than x naught, less than equal to x naught, and it's equal to half by the geometry. You can easily understand that since it's symmetric. X minus x naught is symmetric around 0. So that's the idea. So this is the basic idea. This is like really easy because it's integration x naught to infinity, and into x naught to infinity, this is exactly this integration, which is equal to half. It's very easy to understand because of the symmetric stuff. Why this is true? Because you can prove it mathematically that f of x naught plus z is equal to f of x naught minus z. So these two are same actually, same sides, like same stuff. Perfect. So this is a basic idea, and therefore what we get, let's see the conditions, let's see the options over here. That therefore since symmetric around 10, so probability x greater than 10 must be equal to half. Okay, must be x greater than 10 must be equal to half. Okay, and since it's symmetric around 10, and therefore x greater than 0 is what? So probability x greater than 0 is actually probability x less than equal to 10 and greater than 0 plus probability x greater than 0. Okay, and this is actually equal to like this plus half. So this is a very good idea of understanding that this is always so. Yeah, but there can be a small problem. Why I'm like thinking about this, because there can be the thing that in discrete distributions there can be a case where it's यहाँ पर 1 and between 0 and 10 there is nothing else. Okay, and so greater than 0 must be like there's nothing else. Okay, so that can be a big problem. Okay, it can be like this, there can be nothing else, and so in that case it must be exactly equal to half. Okay, so because this part will be 0, then this part will be 0. If this part is 0, then it's exactly equal to half. So if it's greater than 0, then it's exactly equal to is greater than half. So if this part is 0, that means this part then I think this part is 0, and let's say it starts from 11. So I think then probability x greater than 0 will be equal to x greater than half x. Oh, by the way, I did some small mistakes. So probability 10 is the symmetric point. I'm sorry. So probability 10 is a symmetric point. So what I am meaning is that here it may not have any value, so it can start like this. So at 10 it may not have any value, and in fact what can happen is that in 0 to 10 and in 10 to 20, since it's symmetric, it will not have any value. Okay, so probability x greater than 10 will start from, let's say, 21. So it is starting like this. Let's say this is a PMF. So in this case what will happen is that probability x greater than 10 greater than 0 is actually equal to probability x greater than equal to 10, which may be greater than equal to half. Let me check. If we just remove this, if we just remove this height such that this sum is equal to 0 as half, so it's greater than half over here, and half since it's symmetric, so then what will happen is that it's equal to half only. Okay, you can understand it from here that if we just make this way. Okay, so let's say I define like this probability. I define like this that we can check that if you define the PMF as probability x is equal to x is equal to, like you did define a geometric sum over here, and you can observe that it's 1 by, let's say 1 by, just let me think once. Yeah, 1 by 2 x plus 1, I guess, x greater than equal to 21. Like it's integers. Okay, integers greater than equal to 21, and similarly for this side, so it's like this is half, this is 1/4, this is 1/8, this is 1/16, and it goes on. This is also 1/4, this is 1/8, this is 1/16. If this happens, it's symmetric around 10, but understand probability x greater than 0 is actually what is happening is that it's actually turning out to be half exactly. So in this case, so here half like sum, here half sum, so this may not hold. So this there must be equality sign over here, greater than equal to 0. So this half, this, because equality case is the case for the discrete case. This is a bit more involved. Understand this, try to understand this. So if it's a continuous random variable, then it's greater than half. If it's not a continuous random variable, then it may not be half. Okay. So this is very important to understand. And yep, so remember this, and this is very super important. So this is greater than half for continuous random variables. For discrete, I give an example, counter example, where it cannot be true also. But if you have some other thoughts, do let me know if I have made some calculation mistakes. Similarly, here it's probability x less than equal to 16. So let's see, probability x less than equal to 16. And probability x greater than equal to 5. You can easily understand that here is a symmetric. Let's do it for continuous versions only. 10 and 5 is here and 16 is here. 16 is here. So less than equal to 16 is this part, and less than greater than equal to 5 is this part. So you can understand that both of them contains a part. So this is equal to probability x greater than 0 plus probability x less than 5 and less than 5, less than 5 and greater than equal to, sorry, I'm doing something wrong. Yeah, x greater than 10 plus probability x less than 10 equal to 10 and greater than 5, greater than equal to 5. This is the extra portion you have. Similarly, here for this, we have extra portion probability x less than 10 plus probability x greater than equal to 10 and less than equal to 16. And since it's symmetric, this will be equal to probability x less than 10, which is half, plus, since it's symmetric, it will be equal to probability x. Like it's 10 to 16, so it will be 10 to 4. Okay, so therefore these two are equal. So we have on one side probability x greater than 10 plus probability x less than, like this one, x less than equal to 10 and greater than equal to 5. And on one side you have probability x less than 10 plus probability 4 less than equal to x less than equal to 10. So you can understand this two cancels out because of two, because half they are, and this is much greater than that. So therefore this is greater than this, which is very easy to understand. But understand these are all holding because of the like if x is a continuous random variable, if it's discrete, the equality case may arise. Okay, only the equality case may arise in this discrete case. So as I have shown in this example, this is a very extreme example, but if you assume it's continuous distribution, then it's only holding. Okay, and this part is really easy. So x minus 10 and 10 minus x are actually x minus 10 and 10, let's see, x minus 10 and 10 minus x are similarly distributed. You're right. X minus 10 and 10 minus x are similarly distributed, because if you do x is equal to z, and if you do this is equal to z, this turns out that it's equal to probability f equal to 10 plus z, and this turns out is equal to x is equal to 10 minus z, which two are equal. So therefore these two probabilities are equal, like the density are equal, therefore they are actually equal. Okay, so personally to me, what I think is that this is the only correct option if you consider discrete case, because there can be like there can be cases of equality over here, just not strictly half equality case. So this is super important. This is a very extreme example to understand. So if you consider continuous, then it's fine. If it's not continuous, then I think D is equal to D is the only correct option. Yeah. So this is my take, guys. I know, I hope you enjoyed the problem. It's a very intricate problem, guys. And okay, so all the best, guys, and I hope you enjoyed it. Do like, share, subscribe, and share to your friends who are practicing for IIT JAM MS 2022. Yeah, and coming back to the IIT JAM MS 2022, next year, if you're looking for some crash courses, short courses for 3 months to prepare yourself, like problem-driven crash courses to prepare yourself for IIT JAM MS next year. So do check out the link below. We have it's in our website, on our website, and also if you want to check the problem, check the link below. There's solve the problem a day link. You can go there and check the website and solve it yourself, and comment your own views, guys, how you did the problem, guys. That's super important. Okay, guys, all the best, and it was nice discussing this interesting problem with you. Yeah, and bye bye. All the best. Stay tuned and stay blessed.